Hey everyone, today you're going to be learning about the derivatives of trig functions. And we're going to focus on this, lost my microphone there. We're going to focus on the six derivatives of the main trig functions. And then we're going to apply those rules to a couple of practice problems involving the product and the quotient rules. Okay, so the first thing you should do is do the Desmos matching activity. So if you haven't already done that, pause the video and get the code from your teacher and do that first. So go ahead and get that done if you haven't already and come back. Okay, so hopefully you did the Desmos matching activity. Here are the cards and the way they match up. So I didn't tell you what each function was, what the derivative was. That's what we're going to do next. But again, hopefully you were able to look at the slopes of the little tangent lines and determine what the derivatives were. Okay, so again, take a look at them if you haven't already done so. And then I'm going to go ahead and change screens. Okay, so we're going to go ahead and write down each of the derivatives of the ones that you matched up and see how you did. So this is the sine curve, and then its derivative is cosine of x. And I want you to be looking for the patterns that develop between each of the functions and their co-functions and what's positive and what's negative, and kind of try and make a connection there. So here's the function cosine of x, and its derivative is negative sine of x. All right, next slide. Again, always remember you can pause if you need to if I'm going too fast. All right, here's your tangent curve, and the derivative of tangent is secant squared x. And then this is cotangent of x, and the derivative of cotangent of x is negative cosecant squared x. The back of your handout asks you to try and put together what these are going to be. So there's only two derivatives, but four choices. I'm going to go ahead and tell you what they are, but if you would like to guess them on your own, go ahead and take a moment, pause the video, and see if you can guess. And again, look for the patterns. So this is the graph of secant, and secant's derivative is secant x times tangent of x. And then this is the graph of cosecant, and the derivative of cosecant is negative cosecant x times cotangent of x. All right, so now you have the derivatives of all six trig functions. We're going to go ahead and use some of your previous rules to find the derivatives. So this is a product rule problem. So we're going to do first times the derivative of the second, and the derivative of secant is secant x tangent x, plus the second, which is secant of x, times the derivative of the first, which is just 1. So that is actually the derivative of that one there. This is a quotient rule problem. So you should be doing low, which is 1 plus cosine of x. Low d high, the derivative of, oops, not plus, sorry. The derivative of the numerator is just 1. So it's literally just 1 plus cosine x. So low d high minus high, the derivative of the numerator then is x. D low, the derivative of the denominator now is negative sine of x. I'm going to go ahead and make two negatives into a positive. And then the denominator is just going to become squared. So this is your final derivative for that one. So really not that cumbersome, just have to know your derivative rules. Okay, and then this is the last problem. So it says find the equation of the tangent. So we're going to be writing the equation of a line when we're done. I have a product rule problem. I need two things. I need a point. So right now I have pi over 2 comma something, and I need a slope. And to find the slope, take the derivative. So that's going to be x squared times the derivative of sine, which is cosine. So x squared cosine x plus, then I take sine and multiply it by the derivative of x squared, which is 2x. So when I substitute pi over 2 in for x, I get pi over 2 squared times cosine of pi over 2 plus 2 times pi over 2 times sine of pi over 2. And since this is 0, this part's gone. These cancel. This is 1. So I have a slope of just pi. Okay, last thing I need to do then before I write the equation is to substitute pi over 2 into the original function. So that gives me pi squared over 4 times sine of pi over 2. And again, sine of pi over 2 is 1. So my y-coordinate of my point is pi squared over 4. And so now the equation of this tangent line is y minus pi squared over 4 equals pi times x minus pi over 2. All right, hope you got this done and you're ready for class tomorrow.